something entering and sink means through which one is leaving. So perfect sources and sink of both carrier types and have no special tendency to inject or collect either electrons or holes. There is no special tendency. It's like a perfect source and sink. So considering the external circuit, for every electron leaving the left end x is equal to 0 of the bar in the figure, there is a corresponding electron entering at x is equal to L. So that electron concentration in the bar remains constant. The electron concentration in the bar should be constant. So we can tell this is the direction of current. So electron motion should be opposite. So for every electron leaving this bar, okay, at x is equal to 0, if an electron is leaving, and electron should enter to the semiconductor at the end x is equal to L. So every electron entering at this leaving from the semiconductor at this left end, one electron should enter at the right end at x is equal to L. So that electron concentration in the bar remains constant at N. It should be a constant value. As hole reaches the ohmic contact at x is equal to L. So I'll draw here. This is our semiconductor. So this is one N and one electric field is applied here. So what they are telling, as a hole reaches the ohmic contact at x is equal to L, this center. Okay, when a hole is reached here, what will happen? Which must be it recombine with an electron which must be supplied through the external circuit. So we have seen electrons enters through this way, right? So the electron will occupy this vacant space and that hole will be disappearing from this end x is equal to L. This hole will be disappearing. So an equal amount of hole has to be generated at x is equal to 0 because one electron is leaving. So when an electron is leaving, a vacant space is created. So whenever an electron is entering, a hole will disappear at x is equal to L and a hole will be created at x is equal to 0. So that should be like that only in order to maintain the space charge neutrality. Now to maintain space charge neutrality, when a hole disappears, another hole has to be created. It is reasonable to consider the source of this hole as generation of an electron-hole pair at x is equal to 0. At this end, one electron is generated, a hole is generated. So this is known as generation of electron-hole pair at x is equal to 0 with the hole flowing into the bar and the electron flowing into the external circuit. So if you are seeing it continuously, if you are considering it as a continuous thing, when electron will be leaving, hole will be creating. An electron will be leaving, hole will be creating. Electron leaving and hole is creating. So electrons are moving from right to left and hole from left to right. So this is about drift and resistance in a semiconductor. So the resistance R is equal to, we have seen resistance R is equal to rho L by W T, or else I can write as L by W T into 1 by sigma. This is the resistance of a semiconductor.